Hey guys, we're back at it with the Yamaha Viking repair. I've got the engine out that you had seen on the previous video, and I've got it here on a temporary workbench where I can spread the parts out and keep track of things a little bit better. The first step of this teardown was to take apart this drive belt housing, which uses 11 8mm hex nut screws. There's a small gasket that holds it against the main housing on the back of the engine, and I found it a little bit sticky to get apart. Once that covers off it exposes the bearing housing, which is that cast aluminum X-shaped component. It's held in with 4 more screws. We take that out of the way, and it exposes the primary and secondary sheaves. So in order to get both of these off, I used my larger impact driver with the 22mm socket. I was expecting a little bit more of a fight than I actually got out of it. It seemed like these came off relatively easily. Compared to the torque that I had seen in the technical service manual. Nevertheless, I was pleased that they both came off so easily. What I find myself doing with a lot of these teardowns is trying to inspect the components as I'm taking them apart, just as a way of not only keeping track of where things came from and the condition they were in when I took them off, but also to see if there's any unnecessary or maybe excessive wear or anything that I might need to buy replacement parts for as I'm doing this. So the next part of this was to take off the main housing section that's held onto the engine. I think this took 8 more of the 8mm hex nut screws, and really there wasn't much holding it on once those screws came off. There's nothing to really stick it to. As you see, it falls off quite easily. So with the drive belt out of the way, we're changing our focus over here to the cylinder head. The cylinder head uses 4 hex nut bolts that are fairly long that extend down into the cylinder itself. And then there are 2 socket head screws on the outside that are on this side facing the camera. In addition to that, there are 2 more hex nut screws that are one underneath the exhaust outlet here, and then one underneath the air inlet on the other side of the cylinder. In order to get access to this, I had to remove the coolant line on the exhaust side of the engine so that I could get access with my socket driver into the hex nut screw. On the back side, it's a little bit easier to get access to, but still a little cumbersome to pull them out. Once I break the nut free with my socket wrench, I'll usually use my impact to run out the screws a little bit quicker. To get access to the 2 remaining socket head screws that secure the cylinder head to the cylinder, I had to remove the camshaft sprocket cover. This was pretty simply achieved with these 8mm hex head screws, and there's a small O-ring that goes around the perimeter of the cover that holds it in place, even though the screws might be removed. Once that's popped off, though, you have pretty clean access to those 2 socket-headed screws. Now I admit I got a little ahead of myself with the disassembly of the cylinder head. Before completing this teardown, I needed to disengage the timing chain, which meant the removal of the camshaft sprocket and the decompressor assembly. This is achieved through the removal of these 4 hex head bolts here. I'm using the large breaker bar at the bottom through the AC magneto cover onto the crankshaft itself. This allows me to turn the crankshaft and the timing chain and that camshaft to the correct position where the piston's at top dead center. This is what's recommended by the technical service manual. With the camshaft detached from the sprocket and the timing chain, I'm back to the 2 socket head screws that are securing the cylinder head to the cylinder itself. Normally I like to use a socket wrench adapter for this, but I couldn't find anything that would get around the features of the cylinder head well enough to give me access. With those 2 screws out, I had to flex this oil line slightly out of the way and detach it from a fastening point midway down the cylinder to give myself enough flexibility to get it out of the way for me to lift the head off of the cylinder. And there you go. The cylinder head is off of the cylinder, so now I'm focusing on getting the cylinder apart. Maybe unnecessary, but one of the approaches that I took was to take this timing chain tensioner off first. I thought I might need to reuse this on my future engine build, so I wanted to get it out of the way. And from there, the cylinder is attached in a similar manner as what the cylinder head was, except now this is directly to the crankcase. So there's a pair of socket head screws down on this forward side of the engine, and then there are 4 more hex nut bolts that extend down through the cylinder and into the crankcase from the top. These were something that I could drive out with my impact wrench, and it made it a little bit quicker to get it out of the way. So with all the fasteners out of the way, I'm using a screwdriver to gently pry the cylinder away from the crankcase. It's free, but it is kind of bound in place a little bit because of the misalignment with the broken piston and connecting rod and the crankcase and crankshaft. So I have to jostle it a little bit to get it to come apart. Once it is apart, though, I found that there wasn't any scoring or damage to the inside cylinder walls, and so it's not apparent to me why it would have blown a rod like this. You'll see, though, that when the cylinder actually comes out, there is some pretty catastrophic damage to the lower extension of the cylinder that extends into the crankcase. This is on the exhaust side of the cylinder, and obviously is not something I have the skill to repair. So we'll be looking for a new cylinder as we do our rebuild. The piston then is like I said, free hanging. It's broken free. The connecting rod's broken free of the crankshaft, so it didn't take much to get it up and out of the way. So we're on to another day here. After getting the cylinder and cylinder head off of this lower half, I decided that instead of purchasing a whole new engine or a remanufactured engine, it's probably more cost effective for me to repair it. I know I can't replace or I can't repair a crankcase like with the damage that's shown here. So my plan of attack is to use the parts from this 2015 Viking engine that are still salvageable inside the crankcase that comes from a 2010 Grizzly engine. So these both use the same crankcase part number, although some of their internals are a little different. And so what I'm going to do is just repackage all of the good parts from this 2015 engine into the 2010 enclosure. The first step of this lower half teardown was to take the oil lines off. So that's something I probably should have done while I was doing the cylinder head and cylinder itself. But at that point, I guess I wasn't sure what my approach was going to be. Knowing what I know now, though, that would have been how I'd probably attack it a second time. In addition to that, taking the coolant line out from the oil cooler, which is near the oil filter, would have saved me a little bit of hassle when trying to get the cylinder and things out from the day before. So now we're looking at the clutch side of the engine. This shaft is what would protrude through into the CVT area, that V-belt and housing that we had taken off as the first step. The clutch housing is secured using 8mm hex nut screws, and there's a small gasket, kind of one of these paper, wax paper style ones, that holds it to the crankcase. I found that to be kind of a stuck-on assembly, so I had to pry gently around the assembly to get it to pop off. The next item then is the clutch itself, which uses a 27mm hex nut secured against the crankshaft. This is one of those nuts where they flatten over one of the faces to prevent rotation against the flat in the shaft that it's mounted on. So once I open that up, then I can use my impact wrench to drive that off. It is a left-hand threaded nut though, so to remove it is to turn clockwise. And I'm using a metal rod to prevent the crankshaft from rotating inside of the crankcase. Beyond that though, all that's really left on this side of the engine is to remove this gear select indicator. Looking now at the rear of the engine, I'm removing this coolant line routing guide. It's this bent metal bracket that straps across both halves of the crankcase. With that out of the way though, I'll turn over to the transmission section where we remove the bracket that holds not only the gear select cable, but also the gear select lever itself. To take the AC magneto cover off, then it's a series of these 8mm hex head bolts that pass through the cover and into the crankcase. They're all the same length, except there is one longer one that passes through the coolant pump at the bottom of the magneto cover. It wasn't obvious to me at first that this is something that I needed to remove as well. Like on the clutch side of the engine, this has a paper gasket that goes around the perimeter of the magneto cover and helps seal the magneto cover against the crankcase. One other thing that you'll find yourself contending with is the magnetic effect of the stator coil and the magneto rotor. Although you'll have all the screws removed and the gasket may be pried free, the magnetic effect is still enough to make it feel as if you've caught on something when removing it. With little jostling though, it should pop free without a problem. The next set of items to come out are the torque limiter, the idle, the starter idle gear, the starter drive gear, and then the clutch. So it's important to have a good diagram to work with for these because they can go in either direction. And so you want something to reference to see how they all go together. When I start to take things apart though, I try to reference the pieces that I've taken off already and hold them up like I'm doing on this AC magneto cover so that I can keep track of the position of items and their relative interface with each other. To take the starter off of the crankcase then, it's two additional 8mm hex head screws that pass through the back end of the motor, and then the front half is held in just with an O-ring gasket that passes through an opening in the crankcase. I found it easier to take this out with the gears removed, but I think you can do it probably without removing anything from the magneto cover. Taking the clutch off is not too difficult. I have this large PVC pipe wrench actually from Cobalt that I'm using as a sheave holder, a method to keep the clutch from spinning when I apply torque with the impact driver. It's a 22mm socket that's used on this, and the sheave holder, or in my case, this pipe wrench, really does a nice job of securing things. Another option would be one of those band clamps or something like that that you might use for real large oil filters. Similar to the CVTs on the other side of the engine with the two sheaves, I was surprised that it didn't take a whole lot of effort to get this nut off of the clutch. What I found to be the larger chore was to get the clutch actually off of the crankshaft itself. Although I tried a variety of different things, what I found to work best for me was to use a small pry bar to apply outwards pressure on the magneto rotor while I gently tapped on the crankshaft. Since I don't want to gall the threads of the crankshaft, I put one of the nuts back in place so that I could tap on that directly. After working my way around the rotor a few rotations, it was able to pop free of the crankshaft, and the clutch was left behind it. There is a small woodruff key that's left in the crankshaft. That's what prevents the rotation of the AC rotor. And so you'll want to make sure that you pop that out and keep track of that prior to sliding the clutch off of the crankshaft. In fact, you won't be able to slide the clutch past that point if you don't. With the AC magneto rotor and the clutch out of the way, we can start taking the gears out of this side of the crankcase. The first of these to be removed is the starter drive gear, which is held in with one of those spring clips that goes around the crankshaft. Once that's out of the way, then we can take off the oil drive gear and the oil driven gear. Both of these gears have these small fold over type washers that are helped to lock them in place once they're tight. And I found it helpful to temporarily jam a screwdriver into the gear mechanism to prevent them from rotating so that I could get enough torque on a socket driver, or in my case a crescent wrench. Taking off the balancer gear includes a whole bunch of springs and these little slugs in an alternating pattern. They don't have a whole lot of compression to them. They're very stiff gear, so I wouldn't be too worried about them flying out of place when you're removing it. But I did put a rag over the top of it just in case when I went to take it apart. The last two items to remove before you can extract the oil drive and driven gear set is a pair of retention features that are used to keep the timing chain engaged on the crankshaft. One extends up through the timing chain cavity of the cylinder, and the second is just held on in this portion of the crankcase. With those out of the way, the drive and driven gears are easy to slide up and off of the shafts, which you've already loosened. The last item to remove from this side of the crankcase is a speed sensor. It's held in place fairly firmly with the O-ring that's used to seal it, so you may have to pull on it a little bit to remove it. Well, if you're still with us after this long, then you're pretty deep into the project. At this point, I'm actually taking out the remaining screws that are used to secure the two halves of the crankcase. I believe it's somewhere between 18 and 20 screws are used, and they're at positions all around the perimeter, both inside of cavities that you've already opened up and exposed, as well as around the exterior portions of the crankcase. These are all 8mm hex head screws, as well as there are 3 larger socket-headed screws required. They all vary in different lengths, so if you have a technical service manual, it's definitely going to help you put things back in the right location. Otherwise, try to take note or take pictures to let yourself know where these screws need to go back in once you reassemble the engine. When the engine comes from the factory, it's sealed with an RTV adhesive at the perimeter of the two crankcase halves. So I use a soft rubber-headed mallet to help pop the seams apart when I'm prying against the two. At this point in my project, I've got both halves of the crankcase separated, and I've exposed all of the internal hardware of the engine. I have a good sense for what needs to be replaced or repaired, and so I'll start to get those parts on order. Thanks for following along with this teardown of this 2015 Yamaha Viking engine. We'll catch you on the next one.